in this session we will discuss about the tiered switching architecture. So what is the switching? Means arrangement of the switches. Switch. Tiered means different tier. Tier means different layers. Different layers. So why we need to different layers depend on their performance and their speed. So based on their speed and the performance, we can analyze the different tier. We will discuss about in detail what are the tiers. You can see here, this is the 3-tier architecture. 3-tier architecture, there is a router. All of us know about the router, and they are directly connected to the internet. So we can say they are edge router. Okay, but router is connected with the switch, right? And also there is some other switches, and there is some other switches. So what happened? For the example, I have a building, I have a office inside a building. This building have the 3-story. 3-story means ये स्टोरी वाला कहानी नहीं है, कहानी वाला स्टोरी नहीं है, ठीक है. Floor, 3 floors. Okay, this is a simple example. 3 floors are there. On the first floor, there is a 100 computers. Again, on the next floor, there is a 100 computers, thousands computer. On the next floor, there is again thousands computer. It is possible. Thousands computer having in a single building, it's not a big deal. इतना तो आपके कॉलेज में भी होता है, right? So what happened if you are using a small switch like this switch, basic switch? Basic switch have the 24 ports. And each port having the speed is 100 Mbps only. Are you getting my point? 100 Mbps. So the 24 ports are here, and all the 24 into 100, how much they need to be calculate? 2400 Mbps speed they must be handle. If this computer is connected with this and this, so there is a this speed is a 2400 Mbps, 2400 Mbps. This switch also have the 2400 Mbps. Data must be managed. So if this switch, this port having the speed is 1 Gbps. 1 Gbps. This link is a speed of the 1 Gbps. So it is possible they can handle, or this link is good for handling the 2400 Mbps. Yes or no? 100% this link cannot handle 2400 Mbps speed. Cannot handle, because the bandwidth of this link is a 1 Gbps or the 1000 Mbps only. But though the complete speed they required 2400 Mbps, means minimum 2 GB. This link must be 2 GB, and not only the 2 GB, if this link is 2 GB, okay, this link is 2 GB, okay, this link is 2 GB, okay. But can you imagine of this link? This link have the load 2 GB? No. This link have the load 2400 Mbps, 2400 Mbps, total 48. And the same condition 2400 Mbps, 2400 Mbps, 4800 Mbps. Now the 400 4000 या 4 GB data is coming from this side and approximately 4 GB data is coming this side. So this link only handled the 2 GB. So what will happen? The link will be slow down. Data will be slow down. Okay, so that is the reason they have divided into 3 layers. Layer first, layer 3, layer 2 and layer 3. So first layer known as a core layer, another layer is known as a distributed layer, another is known as a access layer. So what happened if this computer want to send data to this computer, because this computer how much speed is 2400 maximum. So this computer have the 2 links, 2 Gbps, 2 Gbps, so they can handle easily. Now data will be transferred from this link and transferred to from this link and reach to the switch. That is the reason it is divided into multiple layers. 3 tier. First tier is a core, second is distribution, third one is access. Okay, so there is a access or the edge layer, access layers, and which layer directly connected to the end devices. Another is a distribution layer. One link is connected to the layer 3 switch and another link is connected to the access switch. And the core layer, which is actually used here and directly connected to the WAN routers. That is the reason it is called core switches. So come on the another point, here is 3 tiered. Also there is a 2 tiered. 2 tier architecture. In a 2 tier architecture, for the example, there is a one building. They using the switch. This is having the high speed or the Gbps speed like 10 Gbps. They can handle the data. So these switches are connected with the AS. Here is AS is a access switch. Like this, they are connected like this. Like this. Okay. So now there is a same building is here. Same building is here. But they can handle only 10 Gbps speed for the example. But there is a four computer, there is a building A and there is a building B, but they want to make the connection in between. So of course they can handle only the 10 Gbps speed, but there is a 4 switch, so total speed is a 40 Gbps. So one switch cannot handle. So in this case there is a one more type of the switch established. This switch known as a core switch. Core switch directly connected to the internet in a single building. Either if there is a multi-building, so there is a in between the core switch are used. Understood? Mainly the distribution switch and the core switch is L3 switch. L3 and L2 switch we have discussed already, so not need to be defined here. So these are having the mesh topology. And inside the mesh topology they are connected with each other. So in this case, if any link is down, so redundancy will be maintained. If any device is broken or down, so still the data will be maintained like this. Okay, this type of architecture is used in a big organization. So okay, that's good. Here is a one protocol. It is known as a spanning tree protocol. Because you can see here, like if we see in a previous slide. So in a previous slide, if I am going to take a single example of this topology. So what will happen? This switch will broadcast the data. This switch will broadcast the data. Again this switch will broadcast the data. So what happened, there is a one loop will be generate. One loop will be generate like this, multiple loop will be generated. Multiple loops are there. You can see there is a multiple loops. So what happened, the data will just round and round in a loop, in a single loop. So this loop should not be exist inside the network, and this loop can be removed by the spanning tree protocol. So spanning tree protocol is a protocol which is make the network loop free network. Loop free network. Actually, for the example, I have connected this like this switch, and this switch broadcasts the data, and this switch broadcasts the data, this switch broadcasts the data, again this switch broadcasts the data. So what will happen? The loop will be generated. So it is necessary to make a network loop free. So spanning tree protocol can do it. How can do it? By using one block link. One link will be blocked. So how you can check in your like I am going to move on the packet tracer, and on the packet tracer we will create a link, and also let me show you, like I am going to create a topology simple, and topology is here. I have used a switch, where it is, the one switch, the another switch, and one more switch. I am going to connect all the switch like this. So you can see in this topology, you can see the one link is broken, one link is blocked. This link, there is this link is green, this link is green, this link is green, but this link is in an orange color. So what does mean? There is a simple tree has been created like this. Only one network is there, because this link is broken. So there is a only one link. If this computer will this switch will broadcast this side, this broadcast this side. This will not broadcast on this link, because this link is down or the blocked. So why this link is there? This link is there for any type of the redundancy, like this link is broken, then the data will reach like this. Means just maintaining the redundancy. Means the network continuity must be maintained inside the network. This is the actually first rule inside the network. Your network never will go down. There must be multiple routes. Okay, so what happened? This happened due to the spanning tree protocol. So as its name is a spanning tree, so spanning tree make a tree. So tree always have the two parts. One part is a root, another is a leaf, or the you can say upper root part. Root is main. So what happened in a tree? If the leaf will make a food, so it will go to the root, then it will go on another leaf. Right? Similar happened in a network. If this computer want to send this data, so it will not send directly. It will send to the root, then root will forward. So this is the happened, means one root, other are branches. So you can see if this link is broken, this is the root and these are two branch. Either you can see non-root. So this is easy to remember, root and non-root. So how do you know this switch is root or not? How do you know this switch actually root or not? So how you can check? You just open this, like I am going to open this switch, go in a command line interface, enable and show STP spanning tree protocol and hit enter. Now you can see the one thing is written there on the screen. This root is, this bridge is a root. Okay. On the other router, I am going to do the same thing like this. I am routing using this link, and here again enable and show spanning tree and hit enter. So you can see there is a no any type of the written, like this is the not a root. This is not a root. But in the other hand, you can see on the status of the port or status of the interfaces. There is a two interface. One interface connect to the root, another switch, another, this is connected to another switch. So you can see this is the forwarding state and this is in a BLK. BLK stand for block. This is the block, the root. Block. So you can see easily in here on the screen, you can see this have the one block, one is active. This is the root and this is also non-root. These are the non-root. So now the question is this, how they will identify who will be the root and how they will identify the root. This is the root bridge, this is the bridge A and the bridge B. So how they will identify this computer will be the root or this switch will be the root? How they will identify? They will identify on the basis of the bridge ID. There is a bridge ID, it is called BPDU, Bridge Protocol Data Units. They will exchange their bridge IDs. They are exchange their bridge IDs. On the basis of the exchanging their bridge ID, they will identify like who will be the root. So there two things will be calculated. One is a priority, another is a MAC address. Priority plus MAC address. Priority plus MAC is equal to bridge ID. And they will exchange the bridge ID. Like there is a one switch, another switch, another switch. So what they will do? They will exchange their bridge ID. And the lowest bridge ID is equal to root bridge. When they will exchange their root ID or they will exchange their bridge ID, then after that they will define or they will decide who will be the root. So now the question is that, okay, that's very fine, good thing. Like I have this switch, like come on the topology, I have this topology. Okay, and after some time I found that this switch is not working. What I have found, this switch actually not working. Like this switch is not working. And I have found there is a one switch which is have a good speed. And I just connect this Like in my organization there is a one old switch, and that switch is not working properly. It is old. So I have decided to replace it. Then I went to in the market and buy a switch. Okay, and I need to first on this switch. When the switch will be on, so once they will switch will be on, then this link will be orange color. All the links are orange color. So what happened in between? They are exchanging their bridge ID. How you can simulate, use the simulation, and you will find out they are exchanging their bridge IDs. You can see there this protocol. They are sending and receiving the bridge ID, PDU, and you can see the protocol is a STP protocol are used. Okay, so they will take some little bit time to exchanging their bridge IDs, and after exchanging they will decide who will be the root. So you can see this is the, again I reach and run the same command, and I found this is the root. Actually I have replaced this switch. And what a costly switch. Why? Because costly switch will work with the high performance, having the high performance, having the high configuration, high RAM, high CPU. But what happened? This root is not bridge. This switch is a root. So what happened? If any computer send the data, data will go to the this, then go to the this. If this computer want to send the data to directly to this computer, this route will not use. This route will be used. So what happened? This switch will get more data, and this switch actually need a more performance. But this is not able to handle all the data. So in this case, if I want to make this as a root, so I can make this switch a root and this switch is a non-root. How I can do it? I can do it by using the simple command need to be configured here, and I am going to use the no here, enable show spanning tree protocol, and you can see both are the forward, but this is not a root. So how you can change in a configuration? You can do the configuration and change into the root. So there is a simple command, and which command can be used? Spanning tree. Now put the question mark. So you need to provide the VLAN. VLAN 1 is a by default VLAN. What is the VLAN? We will discuss. Now you can see the root and primary or the secondary. So this is the command spanning tree space VLAN 1, then root, then the primary. So once you will hit enter, and after some time you will find this will work as a root. You can see there is some configuration is going on, means some exchanging, data exchanging, hello packets or the BP DU or the bridge ID, they are exchanging with the help of the STP broadcasting message. And after some time you will see the link, this link is green and this link also green, but now this link is orange color, means broken. So what I can check now, if I can go the Control Z and use the previous command, so you can see this is now the root. Okay, it is called primary root. This is a primary root. So now what is the secondary root? For the example, I have some big organization and there is a one another switch, and also there is some other switches inside the network. There is a one other switch. Okay, this is the topology, and this switch will be considered as a distribution switch, and this switch will be considered as a. So now you can see, guys, this is the topology, and this is, of course, this is the root bridge. If this is the root bridge, then all the data will forward to first this, then forward to another switch. Okay. So but in any case, this switch is broken. This switch will be failed. So what happened? This switch will handle. This switch should we handle all the data. But general process is there. General process, they will exchange their PDUs, BPDU, they will exchange, and after exchanging the bridge ID, they will decide who will be the root. But as a network administrator or my organization want me to configure this root to work as a root when the first root will be fail. Okay, so enable, oh my God. Move on again. So some ports are in a blocking state, some in a forwarding state. There is another type of the STP are used. It is called RSTP, rapid STP. So switching the loop and broadcasting stream issue, I have told you already. For the example, there is a two switches, like one switch, two switch, and the three switch. They are communicating like this. So what happened? Broadcasting means any type of the broadcasting, like ARP packet, ARP broadcasting. So what the switch will do, like this, there is a one PC is connected. They are requesting for the ARP request or the MAC address for this PC. So what they will send? They will send the ARP packet, and the switch will broadcast the ARP packet. Once it will the broadcast, and when the data reach on this, then it will broadcast the data again, only expecting the receiving link. Only data will not be forward on this broadcast. The data will be broadcast on this link as well as on this link. So once the data will reach on here, it will broadcast, again it will broadcast, again it will broadcast, again it will broadcast. So this type of the broadcasting again and again until the frame will not destroy. So when the frame will be destroyed based on the TTL value. If the TTL value is 120 microsecond, so it will take the 120 millisecond, 120 millisecond. So the data will be travel 120 millisecond inside the network. Same if there is 100 of the packets are there. So big broadcasting, thousands of the packet are there. Super broadcasting, even millions of the packet is possible in a big organization. So this type of the loop, it is called broadcasting. Broadcast stream. Broadcast stream. Okay, so broadcast stream occur when switch keep receiving the same broadcast and rebroadcast. Then continually start the flooding the unicast traffic. So that is the reason they have divided into the bridge, root bridge and the normal bridge, and block some state. And this is necessary. You will have to verify the STP, they are functionally correctly or not. So how you can see the STP? Simple command sh show spanning tree protocol command, you can verify. And also you need to verify the physical configuration. So how you can verify and how you can modify, I have told you both of them, right? So again come back on this switch. So enable, and now use the show spanning tree protocol, spanning tree, hit enter. So you will see there is a total links are 3, One link is a forward state, one link is a forward state, one is a block. This is not a route. Because you have already configured this switch as a route, so it is requested to you make this switch as a secondary route. So how you can make this switch as a secondary route? You just go in a configuration tree, and here you need to spanning tree. Then you can use here the VLAN. You need to define the VLAN 1, and then you can use the route primary or the secondary. This is the secondary route. So what happened? The secondary route will work as a route after the failing of the first route or the primary route. Got it? So it was all about the STP. So if you have any question related to the STP, spanning tree protocol configuration, switching loop, and broadcasting storm issues. So is there any question related to this topic? If you have any question, please ask.